Hello everyone, welcome back to Cambridge Group. The last video was about accuracy, in which we learned two topics. One is, if a number is given to you, how we can use round this number to certain decimal places. And the second type of rounding was rounding a given number to certain significant figures. Okay, so basically there were two topics: rounding a number to decimal places or to some significant figures. In this video, we will learn one more topic which comes under accuracy, which is upper bound and lower bound. Okay, so without wasting any time, let us start. So what do you mean by upper bound and lower bound? Let us take one example. Suppose there is a person whose height is, let us say, 180 centimeters. Okay, height is 180 centimeters. And it is given as this height is accurate to nearest centimeter. So I say it is correct to nearest centimeters. Correct to nearest centimeter, what do you mean by this is that, for example, the actual height is 180.2. I mean 180 is the rounded figure which I gave you, but let us say the actual height is 180.2 centimeter, right? It means it is having 180 full centimeters and 0.2 centimeters, meaning it is 2 millimeters, right? Since the answer is given in centimeters, there are no millimeters involved. So basically 180.2 will be rounded to 180 centimeters. Let us take another example. If the actual height is 180.7 centimeter, so the nearest centimeter to 180.7 is not 180, rather it is 181. Okay. If the height is 180.4, the nearest centimeter to the value 180.4 is 180, not 181. Similarly, if I take the value which is less than 180, let us take 179.7. So 179.7, this will be rounded to 180. 179.5, this will also be rounded to 180. But if the height is 179.2, for example, the nearest centimeter to this is not 180, rather it is 179. So meaning is that the values which are lying between 179.5 and 180.5, all those values will be rounded to 180, right? So these range of values I can represent using an inequality. For example, if I take this 180, so this 180 can be represented using an inequality that all the values which are lying between 179.5 and 180.5, all those values will be rounded to 180. That is the meaning of correct to nearest centimeter. If a value is lying between these two values, the nearest centimeter to those values will be 180. Okay. Now one more thing. If the value is 179.5 exactly, as I told you here, that if the value is exactly 179.5, this will be rounded up. Okay, this is a norm of rounding, that middle value will be rounded to the next value. That means if a value is exactly 79.5, it will be rounded to 180. The nearest centimeter is 180. That means this value has to be included in the inequality. But 180.5 has to be excluded because that will be rounded to 181. The next nearest centimeter to that is 181. So this value is excluding the value of 180.5. Okay, so this is the inequality. Now this is called 179.5, which is the least value of all those values. This is called the lower bound. And this value is called the upper bound. And as the name suggests, the value 180 is bounded between these two values. One is the minimum value, second is the maximum value. All those heights which are lying between these two values, they are bounded by these two values. One is called the lower bound, which is the minimum value, and the second is called the upper bound. Okay, I will use the term maximum value and minimum value also, because the upper bound is the maximum value this height can attain, this value can achieve. Okay, and this is the lower value this 180 can achieve. Okay, because that will be rounded again to 180. Fine, so this is the concept of upper bound and lower bound. Okay, let us go deeper into this. Suppose now the height is given as 180.0 centimeters, and it is now correct to just notice the difference that earlier it is just 180. This time I have given with a decimal number which is 0.0. That means this 0 is significant. It is correct to nearest millimeter. The 0 after this decimal point, it only indicates that yes, this value can have, there can be one digit here. That's why it is significant. And this digit, if it is here, let us say it is 1. So 0.1 will be read as 1 millimeter. That's why it is correct to nearest millimeter. If rounding is correct to nearest millimeter, I need to include one decimal point. Okay. So nearest millimeter meaning is that this time I need to round the next number to it. The answer has to be in 0.0. The rounding is done to the next digit. Just like in the previous one, it was 180, there was no decimal number. Okay, so the rounding was by including 0.5 after the decimal point to get the upper bound, and then including a decimal point before 180 to get the lower bound. Okay, I hope I'm conveying the message. So it is 180.0 centimeter correct to nearest millimeter, meaning is its upper bound will be written as 180.05. This will be read as 180 whole centimeters, and it is 0.5 millimeters, because 0.5 millimeter will be rounded if it is equal to 0.05, so it will be rounded to 181, right? So excluding the value 180.05, this will serve as the upper bound, and the lower bound will be 179.95, because the values which are greater than 179 point, let us say it is 179.97, and it is correct to nearest millimeter. Nearest millimeter is 1 dp. Okay, so 0.97 will be rounded to just 1, and that 1 will be added to 179. Okay, so this will be the height. So in this case, this will act as the lower bound, and this will act as the upper bound. Okay, fine. Now, if it seems to be difficult or complex, right, let me give you one trick just to find out the upper bound and lower bound in just few seconds without going deeper into the concepts, what is actually happening. Okay, if you notice here, if the question is about correct to nearest centimeter, that indicates it is nearest 1 centimeter, right? As you can see here, 179.5 and 180.5, the whole range covers is of 1 centimeter length, right? This 1 centimeter length is divided into two equal parts, which is 0.5 just right to this 180 and 0.5 just left to this 180, and that's how you will get the upper bound and lower bound. How? If it is nearest centimeter, which is 1 centimeter, you divide this 1 by 2. You divide this 1 centimeter by 2. What you will get? You get 0.5 centimeter. Now you add this 0.5 to 180 to get the upper bound, and minus or subtract this 0.5 from 180, you get the lower bound. Does this concept apply to the next term, nearest millimeter? Yes, of course. In this case, it was given as nearest millimeter, meaning nearest 1 millimeter. So I can divide this 1 millimeter to get 0.5 millimeter. 0.5 millimeter, if I convert this into centimeters, why I need to convert this centimeter? Because the height is given in centimeters. So I need to write this in centimeters. This is equivalent to 0.05 centimeters. Just divide by 10. That means to get the upper bound, I will add this 0.05 to the rounded figure 180 to get the upper bound, which is 180.05. And to get the lower bound, I will subtract this 0.05 from 180 to get the lower bound. Okay, let us take one more example. If the height is given as 180 centimeter, correct to nearest 5 centimeters. So correct to nearest 5 meaning is you divide this nearest 5 by 2. When we divide this 5 by 2, you get 2.5. So the upper bound will be 180 plus 2.5, which is 182.5, and lower bound will be equal to 180 minus 2.5, which is 177.5. As you can see, the range of values from 177.5 to 180.5 is 5 centimeters. So we are dealing with the nearest 5 centimeters. All the values will be moved just within the range of 5 centimeters. That is the meaning of nearest something. Okay. Now let us take some examples on upper bound and lower bound. So the example says that P is 2W plus H. W is 12, correct to nearest whole number. H is 4, correct to nearest whole number. We need to find out the upper bound for the value of P. Now as you can see here, solution, that P is the addition of W plus H, W and H. Okay. Now the two values are adding and they are giving you some perimeter or whatever is the value of P, whatever this P stands for. I suppose it is perimeter, width and height of certain rectangle. So to find out the upper bound of value of P, two values are added. So if two maximum values are added, this will give you the maximum value. So the meaning is P of upper bound will be equal to, by taking the upper bound of W plus upper bound of the height or H. Right? Simple, because the two values are added together. So the maximum value, if they are added, they will give the maximum value. Okay, so we just need to find out the upper bounds individually of W and H. Now as you can see that W is 12, correct to nearest whole number. Nearest whole number meaning is we are talking about just a single whole number. You divide this whole number by 2, you get 0.5. So you add 0.5 to 12 and subtract 0.5 from 12. So I will say that this W will lie between 12.5 and 11.5. This is the upper bound and this will be the lower bound. Similarly, H will lie between, it is 4, correct to nearest whole number, so it will be 4.5 and this is 3.5. Okay, so P of upper bound will be equal to twice of upper bound of W is 12.5 and lower bound of W is 4, upper bound of H will be 4.5, sorry. Now you must be wondering, if this is not included 12.5, why we are using this value in finding out the upper bound? I will say answer this question like this, that let us say you are not taking 12.5. So what next value will come to your mind? Next in the sense, what is the previous value of 12.5? So you might be thinking that, okay, I will take 12.4. But if I say there are infinite numbers between 12.4 and 12.5, what you will say? Then you will go for 12.49. Again, I will say that there are infinite numbers between 12.49 and 12.5. For example, 12.4995. This is greater than 12.49, but it is less than 12.5. So what exactly number which is less than 12.5 that you will include to find out the upper bound? There is no answer. You cannot find out that number. That's why the limiting value, which is 12.5, has to be included in the upper bound. Okay, that's why we cannot say that W is equal to some 12.49 or some value. This has to be written in the upper bound without the equality sign. Okay, so we need to include this 12.5 and 4.5. So this is 2 into this is 17. So this is 34. So upper bound of the perimeter, if I'm calling this as a perimeter, is 34. This is the answer. And this may come in the non-calculator question paper, which is paper number 22 for extended course, right? Remember, we have the whole syllabus for paper 2 and paper 4. Similarly, for core paper 1 and paper 3, there is no omission of some topics. Syllabus in the sense, whatever question we are doing in extended portion, this we will be done both using calculator and non-calculator question. Okay, there is no division of topic as far as using the calculator and non-using the calculator is concerned. Okay, so we will try to solve each and every question without calculator, right, as far as possible, right? And the examiner won't testify you on the topic such as multiplication and division. So if the division or multiplication is complex, then of course it will come in paper number 4 using calculator question paper. Okay, as you can see here, 12.5 and 4.5, they can be easily added without calculator. So this question may come in non-calculator based, and this whole concept, whatever I have said, is applied to each and every chapter or the topic. Okay, so just try to solve questions without calculator. The first approach should be like this. All right, let us do the second question. Again, it is about the perimeter. It says an equilateral triangle has side 6.2 centimeters. Correct to nearest millimeter this time, because we have 6.2 centimeters. So here we have millimeters, exactly 2 millimeters. Okay, rounded to millimeters meaning. So complete the statement about the perimeter P of the triangle. So as you know very well, that equilateral triangle perimeter is given by thrice the side length denoted by S. If we have to find out the upper bound, so P of upper bound is thrice of P of upper bound of the sides. So basically we need to find out the upper bound again of the side length of the triangle. Now it is given as correct to nearest millimeter. So side length will be inside or between these two inequalities. As I said, it is 1 millimeter. Divide this 1 millimeter by 2, you get 0.5 millimeter, which is 0.05 centimeters. So upper bound for this is 6.25, and lower bound you will subtract 0.05 centimeters from 6.2. So I think you will get 6.15. Yes. Okay, so this is the lower bound and this is the upper bound. We need to use the upper bound. So P of UB, upper bound of P. All right, don't need to find out the upper bound. We just need to complete this statement. So it is just this 3. P will be thrice of this. Thrice of 6.15, and this is 6.25 into 3. Okay, so P lies between 6.15 into 3 is 3 into 5, 15, carry 1, this is 4, 18.45, and this is 18.75. This is the answer. Okay, this question came, as you can see, in 2015. Let us switch to the next question. this one. A metal pole is 500 centimeter long, correct to nearest centimeters. So we can easily write this in now inequality form. Now this pole is cut into rods, each of length 5.8 centimeters, correct to the nearest millimeter. Calculate the largest number of rods that the pole can be cut into. So let us give you the picture of the question. We have a long metal pole like this, and this metal pole is divided into small rods like this. Okay, like this. This is the dashed line that there are some number of rods. Okay, so the length of each rod is 5.8 centimeters, correct to nearest millimeter, and the length of the metal pole is 500 centimeter long, correct to nearest centimeter. This is the question, and we need to find out the largest number of rods that the pole can be cut into. Now, as the question says that we need to find out the largest number, somehow it is indicating me the upper bound. So before that, let us see the question how we will find out the number of rods. So of course you can see here the length of metal pole is equal to number of rods multiplied by the length of each rod. Okay, the length of each rod multiplied by number of such rods, this will give you the length of the whole metal pole. Okay, so we need to find out the number of rods. So number of rods is equal to length of pole divided by length of rod. Okay, so this is the equation which you need to find out, right? Number of rods. Now we need to find out the maximum value of number of rods. So clearly it is indicating us that we need to find out the upper bound of the number of rods. Now pause this video and think that for length of the pole and length of the rod, what we need to use, whether the upper bounds or lower bounds or the mixture of upper bound and lower bound. Okay, meaning what I have to use for length of the pole, whether it is upper bound or lower bound, and same goes for length of the rod. So pause this video and think for just few seconds and then play again. So the answer is that since number of rods is given in fraction, and this fraction has to be maximized. Maximized in the sense that we need to find out the maximum value of this fraction. This can only be possible if in the fraction the denominator is minimum and numerator is maximum. Okay, you keep on reducing the denominator and increasing the numerator, you will get the bigger value. Okay, so to get the maximum value, I will use the upper bound of length of the pole and lower bound of the length of the rod. Okay, so this is equal to length of the pole upper bound, which we need to find out. Now here if I can use the space here, that length of the pole 500, this can be written as, I am denoting this length of the pole by capital L. So with an inequality that this is 500.5 and this will be 499.5. Okay, and length of the pole denoted by small letter, this will be between this is correct to nearest millimeter, so it will be 5.85 and 5.75. Okay, I'm sorry for the space, but just look at the values. Okay, so I'm using those values here. If you are not able to see here, you can see here the length of the pole, the upper bound of that will be 500.5, and lower bound for 5.8 will be 5.75. Okay. Now, as you can see here, this is a complicated one decimal, so I am using a calculator. Okay. So it is 500.5 divided by 5.75. This is giving me the answer as 87.043 something. Okay. Now again you pause the video and think that what will be the number of rods. Why I'm asking this question is because clearly there are two possible ways of giving the answer. One is that if you can round this number, the answer is 87, of course. Okay, final answer is 87. I will say number of or number of rods, maximum number of rods. Maximum number of rods is 87. This is the final answer. This 87 can be obtained using two logic. First logic is that if you round this 87.043, you will get 87. Nothing wrong in it as far as rounding is concerned. But had this number been, okay, suppose one case, the answer is coming out to be 87.66 something. Okay, 667, let us say. Now, if you round this number using the rounding concept, your answer would have been 88. Okay, if someone is rounding this and giving the answer would be 88. But this 88 is wrong. Okay, so the concept is not about the rounding this number, because suppose you have a rod and it 87.667, it indicates that completely 87 there are small rods. There are 87 small rods which are completed, and there is 66.66 of the whole rod which is yet to be completed. So the completed rods that you can cut is 87, whether it is 87.667 or 87.043. Here 0.043, only this portion of the complete rod is cutted. Okay, remaining portion is there to make it as 88. Same goes with this logic, that you cannot say that just by rounding this that answer is 88, because 88, this portion is not yet completed, and it says that how the largest number of that the pole can be cut into. Okay, so you cannot cut 88 whole parts. Completed rods you can get is 87 only. So it is not about rounding, it is about the context of the question, which is the number of poles, which is an integer, right? So here the answer is 87, of course. Okay, let us do one more question, which is this. It says that correct to two significant figures, A is 58, B is 28, and C is 18. Calculate the upper bound for the value of A over B minus C. It says correct to two significant figures. Okay, that means we can introduce one decimal to it. So if I have to find out the upper bound of this solution, that upper bound of A over B minus C, okay, let us say we call this as X. So upper bound of X is A over B minus C. Again, this is a fraction, and within the fraction, in the denominator, there is a difference of two numbers. Of course, to get the maximum value, I will use the upper bound of A. There is no doubt about it. Upper bound of A, numerator has to be maximized, and denominator has to be minimized, meaning I won't use the lower bound of B minus C. Of course, lower bound of complete B minus C should be there, right? This is fine. Okay, I'm sorry, I told we won't do, we will do lower bound of B minus C. So first we need to find out lower bound of B minus C. Now in this case, for two numbers, if I have to find out the lower bound which are in difference, the difference will be minimum if you subtract maximum from minimum. I am repeating. The difference will be minimum if this C is maximum, means if you subtract the greatest amount from the least amount, you will get the minimum difference. Okay, so this C has to be maximum and this B has to be minimum within their own respective ranges of values. Okay, I'm not saying that B is minimum means it is less than C. Had it been less than C, it will become negative. I'm not saying that. Within their respective range of values, within their respective bounds, B has to be the lower bound and C has to be the upper bound to get the difference as minimum. If I have to maximize B minus C, so the logic is the minimum should be subtracted from the maximum. Okay, if there is some rich person, okay, so he want to lose something, suppose he is greedy and he is not very kind or gentle, so he will give, right, donations very minimum, okay, to retain within himself or with himself the maximum value. Okay, the subtraction should be minimum to get the maximum value, right? So here we are minimizing the difference, meaning we need to subtract the maximum from the minimum. Okay, I think I have pointed out this in detail, so I'm not repeating the concept. So lower bound of B minus C will be the lower bound of B. So lower bound of B will be 27.5. How I have obtained this 27.5, it's your job. And C is 18, which has to be the maximum, so upper bound of C will be 18.5. Okay, so this lower bound of B minus C will be subtraction of this, which is I think 9. Okay, and upper bound of A is 58.5. Lower bound of B minus C is 9. So again I am using the calculator. 58.5 divided by 9 is giving me 6.5. This is the answer. Okay, so I think that's enough as far as lower bound and upper bounds are concerned. We have done enough examples. There were examples in which we were adding two numbers, and in this examples two concepts have been utilized in a single question. One is how we can maximize and minimize the difference of two values, and how we can use that difference within the fraction also. Okay, there was some question of fraction, but I have skipped that part. Okay, so this is I think more than now. Okay, so we'll meet soon with the next topic. Till then, thank you. Please put on the comments if you find any doubt in the explanation, or if you want something more or some more specific topic, some worksheet or assignment, please do mention in the comments. Okay, thank you.